Welcome back to Elevate Academy. Today we'll be going through a comprehensive factorization guide. And hopefully this is the last factorization video that you'll need where we break down the techniques of factorization. So without wasting any time, let's get into the first technique, which is finding the highest common factor. Might seem like the simplest, and it is the simplest, but it's the most important rule. Because regardless of the complexity of the problem that you face, we always need to look for the highest common factor first before we try and apply any other technique. And that's really, really important. So let us look at this example. We have a coefficient of 6 and a coefficient of 9. We have a variable x squared and a variable x. So we try and find a number that's going to go exactly into these coefficients. If not possible, then we don't have a common number that will go into coefficients. And then we look at the variables and say, okay, is there a variable that we could take out from both of these and it's not going to leave us with any sort of remainder? And when we look at the coefficients, I think it's clear, it's glaring that the highest common factor will be 3. And when it comes to the variables, the highest common factor is x. So it becomes clear that we're going to take out 3x as our common factor. So how do we get what's within those brackets? So what we're actually doing is when we are taking out a common factor or the highest common factor, we are now going to be dividing each of those terms in our question by the common factor. So now we begin to divide the first term, 6x squared over 3x. And here we're applying some exponent laws. And if you guys are still having problem with exponent laws, please click the link on the top right hand corner, which will take you to the video where we break down exponent laws. Okay, so when we divide this, we are now left with 6 divided by 3 is 2. Exponent laws, 2 minus 1, we left with 2x. And that's how we get 2x in here. And when we look at our second term, we do the exact same thing. 9x divided by our common factor. And then we get 3 here. And with this, 1 minus 1 will give us 0. We know anything to the power of 0 is 1. So we just left with 3, and it's a positive 3, so it'll be plus 3. Okay, we'll be doing a few more examples later on, but this is just explaining how we use the highest common factor. At the end of the video, we'll be going through a few examples with all of these combined. Okay, so the next one is the difference of two squares. So in order for us to use this rule, we need to bear in mind that it only works, very, very important, with subtraction and perfect squares. Now we need to have both of these in order to use this. We can't just have one of them. Okay, so the rule is a squared minus b squared is equal to a minus b into a plus b. So an example would be x squared minus 9. Now remember, this is a perfect square. It's easy to know because it's to the power 2. And this, we need to check if it's a perfect square. And we do know that 9 is a perfect square. And so that satisfies our first condition of being perfect squares. And then we need to make sure that we have a subtraction. And that is exactly what we have. And that's how we know that we can use difference of squares here. So how exactly do we do this? We square root the first one, and that's how we get x. We square root the 9, we get a 3, and then we need to have one bracket with minus in between them and another one with a plus in between them. So relatively simple. Once again, we'll be going through a few examples later on in this video. Okay, let us move on. Okay, there's one more example here. Before we go to grouping in pairs, there's one more example of difference of two squares. So when we look at this, now Everything here needs to be a perfect square, and everything on this side also has to be a perfect square. Both terms have to be perfect squares. So when we look at the coefficient here, we know that 4, perfect square, square root of 4 is going to give us 2, and the square root of x squared is giving us x, and the square root of 25 is 5. And then we just repeat the process, a negative in between them, and then a positive in between them. So relatively simple. Okay, so now we move on to grouping in pairs, a very important rule as well. And this is when we have 3 or more terms and we can't find a common factor for all 3 or more terms, but we can find a common factor in at least 2 of those terms. So in this example, we have 4 terms. There's nothing common amongst all 4 terms, but there's something in common between these first 2 terms, which is an A, and then there's something in common between these 2 terms, which is and x. You could also group this differently with AB and XB, and you could also group it with AC and XC, because in AC and XC, you have something common with C, and in AB and XB, we'll have something common in B. But we're going to do it as we see it here. We're going to group AB plus AC plus XB plus XC, and then we remove the A as a common factor from here, A into B plus C plus X into B plus C, and then we left with B plus C into A plus X. So let us group it the alternate way and see what we get. So now we're going to group AB and XB, and we're going to group AC and XC. So that's going to equal to AB plus XB plus AC plus XC. So we're just looking at 2 terms that have something in common. And in this case, we have B. So we take out B, and as we went through in the first rule, the highest common factor, we're going to divide this term by B, and we left with A. Then we divide this term by B, and we left with X. And we do the same here. So what's common between these two? C is common. And then when we divide AC by C, we left with A, and we divide XC by C, we left with X. And then when we look at this term and we look at this term, we begin to see, okay, we have A plus X, which is common on in both of these terms. So we take A plus X as our common factor. And when we divide this entire term, so I'm just going to show you on the side here, B into A plus X, and we can divide that by our common factor, which is A plus X, that'll cancel off and we're left with B. And when we divide this term, which is C into A plus X, by A plus X, we left with just C, so B plus C. So the answer is exactly the same. Okay, so let us move into factorizing trinomials. I mean, a lot of students tend to have a few issues with this, but it is quite simple. So let us. Okay, so when we look at this, we have x squared plus bx plus c. So what we would like to do is, I'd like to go over how we solve complex trinomials first. So there's a method in which you can use your calculator, but I'm not going to be going through that in this video. So we're going to go through something called the AC method. So we know the standard form of our trinomials is ax squared plus bx plus c. So when we get a trinomial as such, 2x squared plus 7x plus 3, we're going to use the AC method where we multiply a, which in this case, when we break this down, in this example, a is equal to 2, b is equal to 7, and c is equal to 3. So by using the AC method, we first need to multiply a times c. And a times c is equal to 2 times 3. and that is equal to 6. And then now we need to find two numbers that multiply to AC and add, and they equal to the sum of those numbers must add up to B. So when we look at B, 7, okay, let's look at the possible factors of 6. First of all, it's 1 and 6, and 2 and 3. So which of these sets of factors add up to 7? 2 plus 3 is 5, and 1 plus 6 is 7. So when the requirement is that our product of AC, the factors of that must add up to B. So in this example, it's clear that 1 plus 6 adds up to our B, which is 7. And then what we do is we write our first term as is, 2x squared, and we split up our second term into the factors that we have determined that add up to our B value. In this case, we decided it's 6 and 1 or 1 and 6, and we split that up into 6x plus x plus 3. And then what we do is we factorize the first two terms separately and then the second two terms. And in this case, we have 2x into x plus 3 and 1 into x plus 3. And we left with x plus 3 into 2x plus 1. Now let us go back to the previous example, a simpler example, where we have x plus 2 and x plus 3. Just to show you that this rule, the AC rule, is universal. So in this case, A times C is going to be 1 times 6, which is going to equal to 6. And now we want the sum of the factors of 6. And we do know once again that the factors are 1 and 6 and 2 and 3. And we want the sum of the factors to equal to our B value. And we know our B in this case is 5. So it's clear once again that 2 plus 3 is going to give us 5. And that is how we know the which set of factors to actually use. Excuse me. So now we go and complete the process. We'll say x squared. We'll split that up into plus 2x plus 3x plus 6. And then we're going to factorize these two terms, x into x plus 2 plus 3 into x plus 2. And then x plus 2 is common on both sides. So we take x plus 2 as a common factor. And when we divide this term by x plus 2, we left with x. And divide this term by x plus 2, we left with plus 3. So we see that the AC method works for all trinomials, provided that they do have, provided they can be factorized. Let us go to perfect square trinomials. Now, the method that we use in the previous Now let's go to perfect square trinomials. So the method we use in the previous example, which is the complex trinomials method, the AC method, also works here. It's just we have to understand, okay, this is a bit confusing here. This should have been x squared plus, okay, let me rewrite this rule and maybe it'll make more sense. So let's rewrite the first rule as x squared plus 2xy plus y squared is going to equal to x plus y squared. So here as well, this is going to be our A, okay? This is going to be our B. Okay, let me just change this up a bit. Okay, let us now move on to perfect square trinomials. Now, the method that we used in complex trinomials will also work here in perfect square trinomials. And this looks a bit confusing here, but if I just rewrite this rule as x squared plus 2xy plus y squared is equal to x plus y squared. Maybe this makes a bit more sense because what we need to understand, there's a 1 here, that's our A, there's a 2 here, that's our B, and then there's a 1 here, that's our C, and it works the exact same way, which we will see in this example here. So we don't have to really remember these rules as long as we know how to apply the AC method to these sort of examples as well. So let us try this. So in this example, we see that x squared plus 6x plus 9 is equal to x plus 3 squared. So let's assume we didn't know the answer yet, and let us do this example. So our A value here would be 1, our B value would be 6, and our C value would be 9. And now when we apply the AC method, we're going to say A times C is equal to 1 times 9 is going to equal to 9. So 9, we have the set of factors for 9, 1 and 9, and 3 times 3. So we now need the sum of one of these to add up to our B value, which is 6, which is quite clear once again that 3 and 3 add up to 6. So we say x squared, we split up the 6x into plus 3x plus 3x plus 9. And then we factorize these two, x into x plus 3, and we factorize this, plus 3 into x plus 3. And then it's clear that we're now left with x plus 3 into x plus 3. Okay, so once again, now we got this. We see that x plus 3 is common in both these terms, in this term and this term. And when we divide this term by our common factor x plus 3, we're left with x. We divide this term by our common factor x plus 3, we're left with 3. And that's equal to x plus 3 squared. Okay, so let us move on. Okay, so here's another example. It'll be the exact same thing. Okay, so we'll be going through a few more examples. We're almost there. So now let us look at cubic expressions. Sum and difference of cubes. So this is only if you are in grade 11 and 12. So let us look at these rules. So if you have difference of two cubes, again, it has to be a difference and two perfect cubes, then we can factorize it as such. And if we have a sum of two cubes, we can also factorize it. So, but it will be slightly different. So let us look at these examples and let us see what's going on. So when we look at this first example, so what we can see, let's look at the difference that happens when we are going from our difference of two cubes into the factorized form. What we are actually doing is we are finding the cube root of our first term, which is A. We are finding the cube root of our second term, which is B. And then we are squaring our first term in our second bracket to get our second bracket. The square A squared is A squared. Then we are multiplying the first and second term, and then we are changing the sign of that product. So a positive A times a negative B will give us a negative AB, but we change the sign, it becomes a positive AB, and then we square the last term, and negative B squared is going to give us a positive B squared. And you notice we're doing the exact same thing for the bottom one. So A, B, we square the first term, A squared, A times B is going to give us a positive AB, we change the sign, negative AB, and then we square the last term, B squared. And it's exactly the same thing that we're doing in these examples. The cube root of x to the power 3 is x. The cube root of negative 8 is negative 2. And then what we're doing is we are squaring this first term, x squared. We are multiplying these two. We're going to get negative 2x. We flip the sign, positive 2x. And we do the same for the 2, negative 2. And we square negative 2, we're going to get 4. Okay, the same holds true for this next example as well. So what we need to check for, we need to check, okay, do we have a perfect cube? Yes, we do. And we need to now check if it's a difference of two cubes or if it's the sum of two cubes. Okay, let us move on. Okay, this is a bit of a summary on how we approach factorization. We always start off with the basics, checking for the highest common factor. And then we look for our squares, cubes, and trinomials. And it's always important to look for highest common factor first, as we will see in these upcoming examples. So let us factorize the following. So if you want to try these examples, please feel free to pause this video, try the example, and let's check if you get the correct answers. Once again, guys, any questions, please leave it in the comments. I'm here to help. Okay. So when we are factorizing, we're going to follow this process for every single example. First, we're going to look if there's a highest common factor. Is the highest common factor here? Yes, there is. So let us look at the coefficients first. Is there highest common factor when it comes to the coefficients? Definitely. That's 3. Then let us look at the variable x. So now let us divide the first term by our common factor, 3x squared divided by 3x. 3's are going to cancel. And then x2 minus 1 using our exponent laws, we're just going to be left with x. We do the same for 6x divided by our common factor. And as we can see here, these cancel out. 6 divided by 3 is equal to 2, x plus 2. And if you want to just check if your answer is correct, you could just reverse that by multiplying into these brackets. And we'll see we'll have 3x squared plus 6x, which is perfect. And again, that's just to check. So that's our answer. Okay, so now let's move on to the next example. Again, we're going to follow the exact same process. We're going to check for the highest common factor. Do we have highest common factor here? No, we don't. There's no common coefficient. There's no number that can go into the coefficients aside for 1, but we're not going to use 1. And there's no common factor for the variables as well. So then now we begin to look, okay, is this now a difference of 2 squares? Is this a trinomial? Is this a difference of 2 cubes? So there's clear, it's not a difference of 2 cubes, but it's a difference of 2 squares, because x squared is a perfect square. 49 is a perfect square. And very important, we need to check if it's a minus. So it satisfies all the conditions for difference of 2 squares. So we know what we're going to do is we're going to have our two sets of brackets. Here we're going to put the square roots of first term, square root of the second term, square root of the first term, square root of the second term, one negative and one positive. Relatively simple. Factorization on its own is quite simple, simplification. But in the more complicated simplification questions in your exam papers, you'll notice that because it's simplification, we do not think immediately that, hey, we need to factorize this. But most of those problems are unlocked using factorization. Okay, let us move on. So now we're looking at question 3. So let us follow the process again. Do we have a highest common factor? Well, we don't. We don't have a highest common factor here. So can we factorize this by grouping? We could, but we're not going to get very far. But we can see that this is a trinomial. And what we now need to do is use the AC method. I would always say the moment you see a trinomial, try to use the AC method. So in this case, A times C is going to equal 1 times 1, which is 1. The factors of 1, very easy, simple, is 1 and 1. So this can be the only set. So but just to double check, when we add these two, do we get the p value? Absolutely, we do. So what we're going to do now is the x squared plus x plus 1. So we factorize this now first two terms, x into x plus 1. And then here, so what we did here is we grouped this 2 and that 2. So we took a common factor out here. So when x squared divided by a common factor, we get x divided by a common factor, we get 1. And here we can just pull out a 1 and it doesn't change anything. So we have this common factor here, x plus 1, common in both of these terms, in this term and this term. So when we divide our first term, x into x plus 1, into our common factor, we left with x, and we divide this second term into our common factor, we left with plus 1. And that can be written as x plus 1 squared. Okay, you're more than welcome to use the rule for finding this in the perfect squares. But I prefer just to learn one method being the AC method, and that will work for every single trinomial, provided it can be factorized. Okay, so let us use the AC method once again. For this example, A value being 6, B value being 11, and the C value being 4. So we're going to say A times C is going to equal to 6 times 4, which is going to equal to 24. So 24, a little bit more complicated here. When we look at the set of factors, first of all, 1 and 24. Then we're going to look at 2 and 12, 3 and 8, and 4 and 6. Okay, excuse me. So when you look at these sets of factors, now how do we know which one we're going to use? It must add up to our B value. In this case, our B value is 11. So let us try. 1 plus 24, definitely not going to work. That's 25. 2 plus 12, definitely not going to work because that's going to equal to 14. 3 plus 8, that's going to work because 3 plus 8 is going to give us 11, which is our B value. So the next step, we will say, okay, great, 6x squared. And now we're going to break up the middle term into these factors. So plus 8x plus 3x plus 4. So let us look at this. And we'll be better off by just looking at this, swapping these two values, which is perfectly fine because of the commutative property. So 6x squared plus 3x plus 8x plus 4. The reason I swapped this is because we can see that naturally 8 and 4 are more compatible and 6 and 3 are more compatible as well. So now when we factorize here, we're going to look at the first two terms and these two terms. So the common factor between these two is 3x. And when we divide the first term by 3x, which is our common factor, we're going to get 2x. And the second term by our common factor plus 1. And within these two terms, the common factor is 4. We divide first term by a common factor, we're going to be left with 2x. Second term by a common factor, 1. And then we look, okay, cool. This is common here and during those two terms. So we take that out as our common factor, 2x plus 1. And then we left over, when we divide our first term by our common factor, we left with 3x. Divide our second term by our common factor, we left with 4. And this is our final answer. Okay. So now let us look at number 5. We're going to go through the process again. Is there a common factor, highest common factor? No, there isn't. Difference of two squares? Nope, because it's clearly a cube. And then we go to ask ourselves, is it a difference of two cubes? Absolutely, definitely is a difference of two cubes. So what we can do to get our first bracket, we are now going to find the cube root of that, which is x, cube root of that, which is 3. Then we're going to square our first term, x squared. Then we're going to multiply these two. We're going to negative 3x, and we're going to invert the sign. So that's going to be 3x, and then we're going to square negative 3, and we're going to get plus 9. So relatively simple, just applying the rule here. So now we move on to number 6. And as we can see, number 6 looks like it's going to be grouping. So let's try it as it is. We can group those two. We can group those two because there is something common, yeah, which is the A. Yeah, we have the 6 that's in common. But it will also work if we grouped AB and 6B and A squared and negative 6A. But let us try this as it is. So here A is our common factor. Then we divide this first term by our common denominator. We left with A. Divide the second term by our common denominator. We left with B. So then we look at these two terms, negative 6A, negative 6B, and we can say, okay, let us take negative 6 as our common factor. So when we are dividing negative 6A by negative 6A by our common factor, which is negative 6, we are going to be left with a positive A. Good way to check this out is when we multiply this, we must get this term here. So negative 6 into positive A, we're going to get negative 6A. And then we're going to divide a positive 6B by a negative 6, we're going to get negative B minus B. And when we double check this, when we multiply this, we begin to see that we got, just to check this, negative 6 times the negative B, we're going to get a positive 6B. And then we can see once again, we got a common factor in both of these terms. So we take an A minus B as our common factor, and then we left with A minus 6. Because when we divide first term by our common factor, we left with A, second term by our common factor, we left with negative 6. Okay, now let us move on to number 7. Once again, is there is there a highest common factor? No, there isn't. Then we move on to check it. Is it a trinomial? No, it isn't. Is it the difference of two squares? Possibly. Let's look at this. Is 4 a perfect square? Yes, it is. Is x squared a perfect square? Definitely. Is 9? Is 9 a perfect square? Absolutely. And do we have a negative sign in between them? Yes, we do. So this meets the conditions of difference of two squares. So we're going to put our two sets of brackets. Square root of 4x squared is going to be 2x. Square root of 9 is going to be 3. And obviously we fill that in both the brackets. One negative, one positive. Very simple. Okay, let us clear these drawings. Okay, so our last example, something that looks a little bit more complex. So once again, we can look, is there a common factor? No, there isn't. So we ask ourselves now, is this a difference of two squares? Possibly, but not so obvious here. So let us check. The square root of 16 is 4. Square root of 81 is 9. So we're in a good place. Do we have a negative sign? Yes. So let's look at x to the power 4. Is x to the power 4 a perfect square? And the answer would be yes, because x squared to the power 2 would give us x to the power 4. Or another way to check this, if we add a square root, okay, and we square root in x to the power 4, okay, we can rewrite x to the power 4 as x to the power 2 squared. And then when we square root that, we know that 2 will cancel, and we have x to the power 2. So yes, this is a perfect square. Again, two brackets. Square root of this is going to be 4x squared minus 9, 4x squared plus 9. And yeah, we might think we're done there, but we always need to check. Can this be factorized more? This Definitely not. Perfect square? Absolutely. This is a perfect square. This is a perfect square. But this is an addition sign, meaning it does not satisfy the conditions of difference of two squares. So be careful of this. So then when we look at the first bracket, however, we realize, okay, so let's write down the part that we can't factorize first, 4x squared plus 9. And let's look at this. This can be factorized because we can make that into 2x minus 3 and 2x plus 3. Okay, so that's where that comes from. Okay, so now we just check once again. Any common factors? No. Difference of two squares, trinomials, no. Then we are done. I hope this video assisted you guys getting a better understanding of factorization. And now we're going to be putting everything together as we begin to revise and prepare for the June examinations. If anyone requires personal assistance, please leave a comment on this video or contact us on our email address that's in the description. This PDF will also be available in a link in the description. I hope that this helped you guys. Thank you.